Today we're going to be looking at 1.7. It's kind of a more difficult section out of all the ones we've done so far. So we're going to spend a little bit additional time on it and doing this and then doing like an activity to follow up with it because a lot of students struggle with it. But it's called rewriting formulas. So how do you solve a formula specifically for a particular variable? We're going to be manipulating formulas and solving for different variables. Example 1. Justin Case is an engineer for a barrel manufacturing company. He wants to design a cylindrical barrel to hold up to 500,000 centimeters cubed and is considering several different radii and heights. To do this, it is useful to solve the volume formula for H in terms of V and R. Okay, so what we're going to do is we're going to look at this formula that's up here in part A, and we're going to look at it and solve for H. That means get H by itself. This extra part here in terms of V and R, that just means we're going to be getting V and R together on one side of the equation. So we're actually manufacturing barrels, so let's draw a quick barrel, which mine's not that good. Something like this. And we're holding up to 500,000 centimeters cubed. So we're actually talking about the volume of how much it can hold. And we're going to be changing the radius. So here's the radius. That's R. Radius is from the center of the circle to the edge. That's your radius. And then the height of the barrel is something else we're going to change. So as we change the height and the radius, it can hold different volumes. So we're going to solve part A, solve the formula V equals pi r squared h for h, get it by itself in terms of V and R. So we're trying to get h here all by itself. So how do we do that? Well, let's copy down the formula first. V equals, this formula is actually the volume for a cylinder, or a barrel in this case. R squared h. Let's rewrite that here. So how do we do that? How do we get h by itself? Well, if we look at this, all we have together between all three of these terms here is multiplication. We have pi times r squared times h. So how do we move them to the other side? It's just the opposite symbol of multiplication. We have to do division. So I'm going to divide both sides by what? Well, since we have all these things being multiplied together, I'm going to divide by both of these things, pi and r squared. Now you could do this one at a time if you wanted to, but pi and r squared. I'm going to do them both. So what happens on this side is r squared cancels out with r squared. Pi's cancel out with pi. And then we end up getting this formula over here. H is now by itself. So it's H equals V all over pi r squared. So, why is this useful? Well, we're going to see in a second. It depends on what we're looking for. Sometimes it's better to use this formula in this form rather than the original one for finding volume. So that will kind of lead us into the next couple parts here for B and C. For B, find the height of a barrel. So we're trying to find H. Right? Find the height of a barrel. When the radius is 30 centimeters, that's R radius, that will contain 500,000 centimeters cubed of liquid. When you're talking about how much it contains, especially in a 3D object like a barrel, that is your volume, how much something is contained. That's the volume. So in this particular case, if you're trying to find the height, what is better as far as what formula you want to use? Do you want to use this formula up here, or would it be better to use this one? The H equals V over pi r squared. The best way to determine this is whatever you're trying to find, H, should be the one that has a variable all by itself. And so this one has a variable H all by itself. So we're going to use our new formula, and it's a lot easier because all we have to do on the right-hand side is plug in the numbers, plug in V, plug in R, and just do division. Multiply and divide, that's it. And we're done. We don't have to manipulate anything else. So what's the volume? We're going to do 500,000. 500,000 all over pi. And then our radius is 30. So it has to be 30 squared. Now everything is all contained. We just have to do this in a calculator and we're done. If we actually tried using this one up here, we'd have to do all this extra work that we tried to do beforehand to get h by itself. We could plug in the values, but we'd have to do some extra math work. So now having this is much better. So let's go ahead and do that. We're going to do the bottom part, which is pi times 30 squared. If you want to use 3.14, which is what I'm going to use for pi, I'm going to do that times. So 30 times 30 times 3.14 is what I'm going to do, which is 2,826. And the top is 500,000. And then we divide. So 500,000 divided by 2,826. I got 176.9. And what is this in? What's the height? What's this? It says up here somewhere, right? Probably centimeters, since it's centimeters cubed here. So centimeters. So that's how high it would have to be. Almost 177 centimeters. So in this particular case, it was best to use this formula we created up here because we're trying to find height. And that's the variable. It's all by itself. All right, part C. What is the volume? So now we're trying to find V, the volume of a barrel with a radius of 5, so that's R, and a height of 25 centimeters. That's H. So now if we look at our two equations up here, which one's better? If we're trying to find volume, it's best to use the one that has volume already by itself. Then we just plug in the numbers on the right, and that will be our answer. V equals pi times R squared, so R is 5 squared, times H, which is 25. So pretty much everything's done. We just have to put this in the calculator and we're done. We'll get V equals, so again, I'm going to use pi as 3.14 when I put in the calculator. So 3.14 times 5 squared, which is 25, times 25 again. This looks like I got 1,962.5. So these numbers will be slightly different depending on what you use for pi. So let me show you one intermediate step is what I did. If you do 5 squared, you get 25. It's 25 times 25. Oh, this is messing up on me a little bit. And then 3.14. So if you change pi to 3.14, change 5 squared to 25, then I just multiplied these three together and got this answer. And this would be in centimeters cubed. So most of this lesson, I think, is manipulating a formula, trying to get a variable by itself, and then applying which one would be better to use in the situation. So for part C, it was better to use the volume formula up here, and then in part B, it's better to use the second one the part A one we had, which was the H. Okay. So the difference between exact and approximate solutions. So this is kind of where we're going to apply the whole pi thing that we talked about when we changed it to 3.14. Exact answers, they don't use a rounded answer. So usually when you see pi, you kind of keep that as in your answer. So that's exactly where it says note. We're going to keep pi in your answer. Approximate is when you actually do have to round something. So anytime a number is actually rounded, it's called approximate. And then equivalent formulas is actually the thing we just did in part A in the last problem. This formula here is equivalent to the one up here. They're exactly the same thing, just written differently. So it's two formulas with identical values, right? They all had the height, the radius, pi, and the volume. They're just solved for different variables. So if I go back to part C, it says express the answer in C as an approximation and as an exact answer. So if we go back to part C, this here would be an approximation because I had to put pi in my answer, which is a decimal, and we had to round it. Actually, I don't think we had to round this one. It came out to be 0.5. But if we use the value of pi, since it goes on forever, you would get a long decimal as well. So we ended up rounding it. we rounded pi instead of rounding the final answer. However, if we go back to this original thing here, pi 5 squared times 25, we would just multiply what we could, the 5 squared and 25, and leave pi in our answer. So as an exact answer, let's try this. As an exact answer, this would be v equals, let's write that out again, pi times 25 times 25. We would only put together what we could, the two 25s. So if you do 25 times 25, you get 625. So as an exact answer, we would write this as 625 pi. We would know to multiply them together, but we do not want a rounded answer. This would be an exact answer. As soon as you use pi, since it's a digit that goes on forever, you would have to round it at some point. We could also add the centimeters cubed, I guess. So that's the difference between exact and approximate. All right, example 2. A couple left here. Using the formula a equals 1/2 h times b1 plus b sub 2, solve for b sub 1. This little thing here is called a subscript. So usually they call it sub, like b sub 1 or b sub 2. It's just denoting that there's two different bases, I guess, in this case. You have a base 1 and a base 2. So what we're going to do first is we're going to copy down the formula. A equals 1/2 h b sub 1 plus b sub 2. And we're solving for what? B sub 1. So we have to unpack all this and figure out how to get this all by itself. Our goal is to get b sub 1 by itself. This right here. That's kind of dark. Shouldn't have done that. So how do we do that? Well, we have multiplication between 1/2. We have multiplication between the h. And then inside the parentheses, we have two things being added together. One thing you could do is you could distribute, right? I'm actually not going to do that in this case because it's going to make things more complicated. So I'm going to show you a different way of getting rid of everything else that's around here. Since you have multiplication here, 1/2, I might write that as a decimal to make it a little easier. So maybe let's rewrite this as a equals 0.5. That's what 1/2 is. H b sub 1 plus b sub 2. Might be easier not to deal with it as a fraction. So since we have multiplication between all these things here, before you get inside the parentheses, I'm actually going to divide both sides by the 0.5 and the h. Very similar to the last problem we did together, which was we divided by pi and r squared. Since we have multiplication between everything, we can do that. You could distribute this in this problem, but we're not going to. It just takes longer to distribute and do it that way. So on the right-hand side, the 0.5s cancel, the h's cancel out. The left-hand side, just get a divided by 0.5h. And the right-hand side, everything's gone except for the b1 and the b2. b sub 1 plus b sub 2. Since there's nothing outside of it anymore, we do not need the parentheses. So we don't need it anymore. We just have this. We're actually almost done. We're getting b sub 1 by itself. I'm just going to bring the b sub 2 over. Since it's addition, I'm going to subtract it. Now this looks kind of messy here, but all of these variables and stuff, none of them are like terms. So these are just going to have to stay separate. You're going to have your fraction first, a over 0.5h minus b sub 2. It's all going to be written on one line. And now b sub 1 is all by itself. So when would this specific equation be useful? Is if we were trying to find b sub 1. If they gave us one of the bases, b sub 2, if they gave us a, which I think is the area in this case, and h is the height, then we would be able to find b sub 1 very easily just by plugging in the numbers and solving. A lot easier than dealing with this original equation. The only time you'd use this one is if you're trying to find the area, a. So I think this takes a lot of practice. It's like we have to practice a lot with manipulating the variables and stuff, because it's weird that you're doing something to both sides, but yet it doesn't simplify, right? You have to keep it in that specific way, a over 0.5h, which seems weird, and you just kind of carry that through the problem. Okay, we're going to go back to kind of what how it was written back here, where you have to solve for h in terms of v and r. So we're gonna do the backwards of it. We're gonna look at an equation and then write it out in words, what it's saying. So it says in A through C, complete the sentence. Blank is written in terms of blank for each given formula. So whatever comes first is what it's equal to. So we say A, the variable all by itself, is written in terms of, you might think it's s cubed, but we're just talking about the variables here, just the variable s. And part B, v is all by itself. So v is written in terms of what are the variables? Capital B and h. And they're also telling you what these formulas are for. The first one was for an area of a square, the second one for a volume of a pyramid. And the last one, this may look familiar, just be careful how it's written. H is on the other side. So what is written in terms of what and what? We would say that H is written in terms of V and R. Whatever comes here is whatever is by itself. If H is by itself, that comes first. Up here, V was by itself, A was by itself. So you should be able to understand these directions of what you're trying to solve for if it's ever written like this. All right, we have one more to do. I don't know if I would do any more with you or not. Might do one, I'm not sure. Example 4, the formula C equals 65t over r minus 65. It computes the number C of hours needed for one car driving r miles per hour to catch up to another car that has t hours ahead and driving at 65 miles per hour. That's a pretty loaded thing right there. That sentence is pretty loaded. Solve the formula for t. This is what really matters. Solve for t in terms of C and R. So we're going to get t, I'm going to circle it up here, t all by itself. So what's this doing? The number of hours needed for one car driving a certain speed to catch up to another car that's already ahead of them by so much time. So you just have a car trying to catch up to another car. And the car ahead, I think, is constantly going 65 miles per hour, which is kind of where the 65 comes from in the formula. All right, so let's copy down our formula. So we have, I actually have 65 on top and bottom. So C equals 65t all over r minus 65. So how in the world do we get t by itself? It's a pretty tough one. So we want to get rid of everything else. What I would probably do is make sure we don't have a fraction anymore. And this doesn't simplify at all. You cannot just cross off the 65, so you're not allowed to do that. It doesn't work that way. We have this thing down here connected, like this r minus 65 is a quantity together. So I am going to get rid of it. Since it's in the denominator, I'm going to multiply it as a numerator. And I'm going to use parentheses, r minus 65, technically over 1. So what this does over here on the right-hand side, it's going to cancel the two out. That's what we want. We have one on the top, and we have one on the bottom. It's just like seeing the number, 7 over 7. They cancel out and become 1. That's what's going to happen over here to the right. Now, whatever you do to the right-hand side of the equation, you have to do to the left. So I'm going to multiply this by r minus 65. I guess we don't need this anymore. This here. This is a pretty tough step to understand. Hopefully you're okay with that. And all we have left on the right-hand side now is 65t. Left-hand side, we have r minus 65 times c. I think I just might put the c out front. Usually you see the number or variable out front, and then you see the parentheses set, r minus 65. This is in parentheses because if we were to multiply this through, we'd have to distribute it. Although I'm not going to waste the time doing that, but you could if you wanted to. And maybe I will, I don't know. Right now my goal is just to get t by itself. So I have that written on the other side, we're good there. And I'm going to divide by 65. So why am I doing that? Because between these two you have multiplication, so to undo it you have to divide. Do it to both sides. These cancel. So t is now all by itself. And I will distribute this to show you what it looks like, but you don't have to. So one way is to keep it like this, exactly the way it's written, or you could say it's c times r minus 65c all over 65. Either one's fine. You could keep it like that, or you could just rewrite it like c times r minus 65. Sometimes it's useful to continue simplifying, but in this case it's not really. Actually, it gives you more variables, which isn't great because you have, multiple c's up there now. Bottom 65. So either one is fine. T is by itself in both cases. Now, when would it be better to use this formula instead of the original one? If we were trying to find the number of hours that the car was ahead of us, that goes back to up here, to catch up to another car that is t hours ahead of you. So a car is like 2 hours ahead of you, and you're trying to catch up to it. You're trying to find how much time it's ahead. That's when you would use this. And I think that's in the huddle. You're going to be using one of these formulas. So if you look at the huddle, right, example 4, it's using the exact same formulas. So like if you look at part A, it's going to tell you, a car is 2 hours ahead. So it's giving you T. It's giving you R. Find C. So which one's better to use? Oh, we're going to try to find the one. We're going to use the one that has C in it all by itself. If we're trying to find C, which one has C all by itself? It's actually the original one they gave us. It's written on here. I'm not sure if it's on your paper or not there, but it's back here. We're going to use this equation again. So you would actually use this equation and then plug in the numbers. Because we have T is 2. The bottom would be R, which is 75, minus 65. And then you would solve this side. It's a lot easier than using our new one, right? We wouldn't want to use this one. However, if you look at part B, now it's asking how far ahead is the car if you are driving at R is 85 miles per hour for half an hour, 0.5. We're finding T. That would be when you use this formula back here. So I'm going to use this one here. It would be T equals C times R minus 65 all over 65. Plug in the numbers. What's C? 0.5. And then R is 85 minus 65 all over 65. Then you would solve this and get a value for T. You guys can do this. I'm not going to do it. Just plug in the calculators. You can use one on your laptop. So in this particular case, you would subtract the 2 first, then multiply, and then divide by 65. 2 is multiple choice. 3 is a little tough. I might go through that one. I think the other one's okay. Let's go over this one real quick, and then we'll be done. In chemistry, a given mass and volume of gas will satisfy the equation. So when you get to chemistry, you'll probably see this equation a bit. P1 and T1 are pressure and temperature at one time, and then P2, T2 are pressure and temperature at a different time. So just different times. So you have temperature and pressure. What is an equivalent formula to solve for P2? So our goal is to get this by itself. So you have T1 over P1 equals T2 over P2. So how do we get P of 2 by itself? Well, I'm going to probably do, didn't I do one like that before? I was trying to get something on the bottom. I don't think I was trying to get something on the bottom, but remember back here, I got rid of the fraction part by multiplying both sides by the bottom part. I'm going to do that here as well. I don't want P2 to be in the denominator. My goal is to eventually get P2 in the numerator equal to something else. So I don't want in the denominator. Let's get rid of that. So I'm going to do on both sides, I'm going to multiply by P2. Technically over 1. Do it up here. P2 over 1. So what happens on the right? Just like before when we did it with, I think, R minus 65, these cancel. And now, actually right now what we have is T2 solved by itself. But that's not what we wanted. The left-hand side, you multiply across the top. They just sit next to each other with multiplication between the two. P2, T1. All over the bottom would be P1. So now we have some extra work. We're trying to get rid of P2. Now that we have P2 in the numerator, we can get rid of everything else. So to get rid of P1, we would multiply by P1. Let me rewrite that. P1 over 1 times P1 over 1. So what happens here? They cancel. The first step is kind of difficult because I was trying to just get P2 to be in the numerator. Now that it's in the numerator, I have to get rid of all this other junk around it. On the right-hand side, you have T2 times P1. Hopefully you can see how that happens. The ones are on the bottom. You just put them top two together. Oh, and I forgot one because P2 is not by itself yet. We have P2 times T1. Just bringing that down. And then lastly, we're going to get rid of T1. Since it's multiplication, we can divide on both sides. They will cancel. And so I'll write up here, we actually have P2 by itself now. It's P2 equals T2 times P1 all over T1. This one is pretty tough too. That's why I want to go over it. When you see multiple fractions like this, it can be tough to figure out what to do. Some people do something called cross multiply. You could also do that. I'll take you through that real quick. If you were to cross multiply, that means you have two fractions equaling each other. You can multiply these two together and multiply these two together and then finish off from there. So what you could do is do T1 times P2. A lot of people don't remember this though. Multiply these two together and multiply these two together with the equal sign in between them. And then T2 P1. So that's one way to do it, cross multiply. And now as you can see here, we're basically on this step over here where we're dividing by T1. It's a little faster to do it this way to get the same answer. But again, I don't think a lot of students remember you can cross multiply, or maybe you've never done it before. I don't know. So everything else you should be fine to finish up. And so do the rest of the huddle and the mastery. And if there's any other homework assigned. And that is all for 1.7.